Hello everyone and welcome to our virtual public talk series. I'm Dr Sheila Kanani, the Education, Outreach and Diversity Officer at the Royal Astronomical Society, which encourages the study of astronomy, solar system science and geophysics. I'm honoured today to introduce you to our guest speaker. She's a very dear friend of mine and a Glasgow University planetary science PhD student, Áine O'Brien, and Áine is going to be talking to us about her, she was part of a discovery of the UK's first meteorite to fall in the last 30 years. And we're celebrating the 1 year anniversary, which is coming up soon. She's going to talk about what it was like to be part of the search team scouring the Cotswolds for fragments in lockdown and her experiences studying the stone in the lab in the months since. Áine is a final year planetary science PhD student at the University of Glasgow. Her research focuses on the detection of organic molecules in Martian meteorites, carbonaceous chondrites and Mars analogues, and the development of techniques in preparation for Mars sample return. During her PhD, she remained extremely busy, including working as the diversity officer for the RAS while I was on maternity leave last year. Áine has also helped to establish the RAS's early career network, which she is now the vice chair of. And prior to her PhD, she was a physics and astronomy teacher in Suffolk. In her spare time, Áine likes to make the most of the Scottish hills and her friends' pets. I wonder if she's got her own. A quick reminder that there will be a Q&A after the talk, so please get your questions ready, either via Zoom or YouTube, depending on where you're watching. Thank you to everyone for being here today, and thank you to Áine for being with us today. Over to you.
Thanks so much, Sheila, and thank you so much to the RAS for inviting me to chat to you folks today. So I'm just going to share my screen, and hopefully, if Sheila, you could just give me a thumbs up that all is okay.
That looks good.
Excellent, amazing. Okay, as Sheila said, my name's Áine. I'm a final year planetary science PhD student. And I'll be talking to you today about the Winchcombe Meteorite, which fell almost exactly a year ago. It was by far the coolest thing to happen to me during my PhD, and certainly really the good news I needed a year into the pandemic, especially because this time last year, I sadly just lost a family member. So, like all big news stories in this day and age, our story starts with a WhatsApp chat screenshot. She says, if she can get it moving. Here we go. This was the message history between myself and a colleague on the morning of 1st of March last year. I'd spent late that night before frantically scrolling Twitter, though I do kind of do that most nights, and I especially did it in lockdown because what else was there to do but despair at the state of the world. But that night I wasn't despairing at the state of the world. I was actually really excited for once, because all over the internet, there were pictures of this amazing fireball. So in the morning, I texted my friend Luke to ask him, did you guys pick up the fireball last night? To which he responded, yes, I just woke up to some very excited emails. I asked him if there was a fall, perhaps if they thought there might be, and he said probably, but there'd be lots of small fragments. I asked if it might be found. He said that lockdown might make it tricky. And I asked if actually they might even have been able to find out where it might be, because these videos had come from all over the UK, even in continental Europe as well. Then at 9 a.m. on the Monday morning, I get this text. Don't spread it yet, but we're about to issue a press release saying we estimate that a meteorite could have landed between a point just north of Cheltenham and Stow-on-the-Wold. So before we get any further in the story, a quick crash course, excuse the pun, in the world of things that are floating around in space that aren't planets, moons, or old Teslas. What do we have in the solar system? We have comets, we have asteroids, we have all these sorts of things. What are they? What's the difference? So a comet, we often call those a kind of dusty snowball, icy snowball, dusty ice ball, all these kind of things. These are our beautiful ice balls that have lovely elliptical orbits that glow as they come towards the sun. We have asteroids. These are our rocky bodies that most of them are found in the asteroid belt in between Mars and Jupiter. These are mostly just rocky, dusty things. we have meteoroids, which are basically fragments of planets, of comets, of asteroids, of moons even, floating around in space. When our meteoroids actually come in towards the atmosphere and start to burn up, that's then they become a meteor. So when they become a streak of light, a shooting star, they are a meteor. When a meteor lasts longer than about a second, that's about long enough that if you saw one and you pointed to your mate and say, look over there, and then they still saw it, it's still going, that's when we call it a fireball. And then if that fireball actually lasts long enough to make it to the ground and doesn't burn up, that's when it becomes a meteorite. So that's a fragment of a meteor that's made it all the way to the ground, to the surface. And those are really great for us planetary scientists because we can study them. They give us a snapshot of all kinds of different places in the solar system, and they're really, really important to us. So we need to find them when they fall. And the way we do that, we need to be able to detect them and catch them on cameras. And so it just so happens that we have a network of cameras around the UK, and that colleague of mine who I texted that morning set up or helped set up the UK Fireball network. So this is a network of cameras on rooftops all around the UK in areas of dark skies. And these are these beautiful, massive like basically SLRs with a kind of body with a sort of fisheye lens on them, hooked up to a Raspberry Pi. And then some very clever mathematicians have made some and computational scientists combined with some planetary scientists have made some clever code that can tell apart a satellite from a shooting star, from a fireball, from anything else going around in space, all of Elon Musk's Starlink satellites, for example. And they can say, we've just seen a fireball go past. And if enough of our cameras can detect it, they can work out exactly where it might fall. But it's not just one network that does these. Loads of these things are really valuable. Meteorites are really precious. So loads of people work on these things. And it just so happened that about a year or two before COVID, but also it might be less or more. I mean, what even is time anymore? I don't know about you. I don't know, who knows when it was. Sometime during my PhD, a whole bunch of people from loads of institutions got together and said, we haven't had a UK meteorite in years, and we should have done. We've all got these expertise and with cameras and amateur astronomers and citizen scientists. We should come together and kind of discuss what to do if. And really lucky they did. And they formed this thing called the UK Fireball Alliance, which is amazing because it sounds just like something like the Avengers or something. And they sat down and they even made a press release that is like, just to fill in the gaps on the day, which is why they were able to get that press release out in less than 12 hours after that first fireball. Amazing stuff. So people from all over got together and said, okay, this is what we will do. Obviously, they didn't anticipate there being a virus going around that shut down the world at the time. But really glad they did, because on the 28th of February, there was this beautiful fireball. What I have now for you is a really lovely video, and I'm just going to show you it and not say anything for a second. Just let you watch it. So what you'll see, this is a film of the Winchcombe fireball as it streaked through the sky. This is taken by the camera belonging to a guy called Richard Fleet of the UK Meteor Observation Network, or UK MON as we call it. As you can see, it's a really bright thing. You can kind of see it flickering, gets brighter and darker. Maybe you'll see it sort of seems to have almost like spots in it. That's because that's what made us think, oh, this thing actually broke up, and I'll tell you about it in a second. So really amazing. And it was not just seen by scientists, it was seen by people all over the country. And it was tweeted about, it was posted on Instagram. What it was really blew my mind was people's like doorbell cameras detected it. Even there were amazing videos, I think it's called Hive or something, the Amazon thing. They had amazing videos from that and they sent them in, which meant we could use all those videos to really constrain exactly where this thing is. And what ended up happening is that it ended up being the most well-recorded fireball ever, as in we got so many reports of that fireball. There's never been a meteorite or fireball with so many detections before, which was amazing. And what that meant, we could do our own track and trace. Over that night, over that 12 hours, they were able to pinpoint really well where we think that thing was going to be. And so, just so happened, doing the maths, some really clever planetary scientists, computer scientists, mathematicians come together and said, we think there's probably a meteorite somewhere in the Cotswolds, basically in this Gloucestershire area. So my colleague, Dr. Ashley King from the Natural History Museum and the UK Meteor Observation Network, goes on telly on that Monday. He goes on BBC and basically says, if you live in Gloucestershire, in this area, please, if you happen to see a black rock where it shouldn't be, tell us. Now, it was really tricky because we wanted them to tell us, but we also didn't want the public to go out searching. It was peak lockdown, okay? So we couldn't just say to any old person, go out there. We had to really be like, control the messaging, because we couldn't encourage people from all over to descend on Gloucestershire because, you know, obviously that was a really, you know, it literally wouldn't have been allowed. So really tricky time. We couldn't just encourage the public, but say if they were going out on their daily exercise, walking the dog, or even just in their own gardens, and if they've spotted something, let us know. And gosh, did they let us know? The Natural History Museum, the Meteor Observation Network, they were flooded with people saying, I found a meteorite. And bearing in mind, we said, look out for a black rock. That's because of the fusion crust when it burns through the atmosphere. We had quite a few things that weren't black rocks, but it was lovely to have the enthusiasm, people really getting involved and being excited. There wasn't much else going on at the time to be pleased about, let's be honest, this time last year. But one of the photos that came in that morning was very promising indeed. This is the famous Wilcock family with my colleague Richard Greenwood from the Open University. He'd seen a photo that came, I think, through to the Natural History Museum of this lump of dirt, if you want to call it that, or looks a bit like smashed up coal. And he thought, let's go take a look at that. He lived in sort of near Oxford, so not too far from the Cotswolds. Obviously, lots of health and safety approvals had to come through for any kind of travel for us, but thankfully all the university's powers that be did allow that eventually. And Richard turned up and he took one look at that driveway, and as he says, his knees went wobbly. It wasn't just a meteorite. He looked at it and he knew straight away it was a really rare type of carbonaceous chondrite that actually he happens to have studied his entire career. And so had Ashley, who was on the telly that very day telling everyone, look out for these things. So it really is amazing. Just the chance of it all was just fantastic. And the family had even, the reason that they had contacted us is that Sunday night, their daughter Hannah had heard this clattering noise, kind of thought nothing of it. She thought that like a photo frame had fallen down or something. And then they saw this sort of lump of dirt in the morning, really just thought, I don't know, someone had chucked it there or something like that. But it was their son who then had seen Ashley on the news and said, no, it's a meteorite, scoop it up, collect it. So just amazing. And they were really careful. They used gloves, they put things in really sterile containers, and really lovely. So that was on the Monday. And by the Wednesday, Ashley was then able to join. And this is a photo of them outside really late at night in the cold, again, to try and be as safe as possible. It was obviously a tricky time, and collecting up as many bits as we could, which was amazing. We had a bit of meteorite, but like I showed you before, there was quite a big area we thought this thing was going to be in. And in that video, it looked like this thing broke up. It looked like there was going to be more sections. So back to WhatsApp again. This was all this was happening unknowns to me at this point. I was excited having seen that fireball, but didn't really know much else. But on the Wednesday afternoon, I get a text from Luke saying, holy moly, just got off the phone with Ashley, and Richard had met with one of the black rock finders and reckons it's a CM chondrite. Ashley is on his way now. Don't spread this. Also, it means we will definitely still go down. And then he sends me a photo saying, this pile of dirt allegedly is it. So bearing in mind, I live in Glasgow. I live in a top floor flat, which I hadn't left in months, really. And at this point, the Scottish government had a 5-mile travel rule that had been in place for like 4 months. So I really hadn't left this like inner city of Glasgow for a very long time. And so Luke was escalating steadily, literally to the very top of the university. Approvals for I think 5 of us from the university to travel down in our own cars to go searching. And it did make it to the very top of the university to say, yes, you can drive down in separate households out of the 5-mile limit all the way 7 hours down to Gloucestershire. And so on the way down, I actually filmed a couple of videos of just how I was feeling, because I hadn't left my flat in so long. And I just realized I'm not sure I actually clicked the thing to share video. So I'm just going to have to go back and just turn that on in the Zoom thing. 2 seconds. Audio. Sorry, I just realized I didn't do that when I clicked share screen. Share sound. There we go. Apologies for that. So hopefully in a sec.
So I am just about to drive.
Can I check? Sheila, can you just let me know if you heard that?
Yeah, perfect.
Perfect. Okay, I'll start it again.
So I am just about to drive down to Lancaster en route to Cheltenham because we are going to go meteorite hunting. So excited. There hasn't been a meteorite fall in the UK for 30 years, and here we are in a pandemic going hunting for one. So this is me just getting petrol. Just got petrol and off I go.
Okay, so that's part 1. Part 2.
So it is 9:06. I am at T-Bay service station and I'm waiting for my colleagues to catch up so that we can go on to our hotel for this evening. Won't be long, and I'm wondering how I'm going to sleep tonight because I am so flipping excited. Just kind of can't really believe that I might be picking up a meteorite tomorrow, or indeed the next day. Yeah, pretty flipping stoked.
So that was just a snapshot of what it all felt like in the build-up. Sorry if that's a bit daft, but the context of this whole thing kind of made it was so wild for all of us involved. And also we couldn't tell anyone. It was all kept completely quiet because we were so worried what the reception was going to be, us turning up in Gloucestershire from all over the country. And also we just didn't want to encourage people who didn't have the health and safety approvals to go searching. But safe to say I was quite excited, as you might have seen. And this is how I reacted when I first arrived and Ashley showed me a piece of the meteorite. No, he is not proposing to me. This is me being shown a bag of the Winchcombe Meteorite. My favourite thing about it is that it's actually, this is a piece that the Wilcox family put into a Waitrose Essentials bag. And I would say it's a pretty essential item, to be honest. So what did we do? Why did we go down? Well, we were searching for pieces. And how did we do that? We basically walked up fields and we walked down them again. A lot of the time they were very nice and flat with short grass, and you're searching for black rocks, sometimes that big, depending on where you are. They can model what the size of it should be. But sometimes you're in really tricky terrain and it's quite hard to search for things. You're going into bushes, you're falling in streams, that sort of thing. It's also sometimes quite hard looking for meteorites because you see a lot of meteorwrongs. You see things that look like dark black rocks that could be meteorites. Just to show you how similar they are, this is just a bit of dirt that I found when we were searching, and this is an actual piece of Winchcombe. Similar size. You can see it's dark with white speckles in it. That's dark with white speckles in it. On a really long day, it's very easy to mix them up. So, yeah, lots of meteorwrongs. A special example, this is a piece of Winchcombe that was found by a professional meteorite hunter a few weeks later. And this is a piece of rabbit poo my supervisor picked up. Nice and glamorous. We spent a lot of those few days picking up poo because it's the Cotswolds. However, there was some upsides too. This is a screenshot of my step count over the whole of the year from the beginning of the pandemic up until March 2021. So you can see April 2020, peak lockdown all the way through. I'm really not getting much exercise, stuck in my top floor flat, and then suddenly I have to go meteorite hunting. Suddenly I'm getting lots of exercise. So that was nice. So we had a few days, no luck, but on the Saturday morning, it was a beautiful morning. This is at 9:20. I took this photo. This is my supervisor. This is a sheep field we're in that day. Beautiful, lovely estate. And we have this moment.
Are you sure? Are you sure? Yeah.
No, yeah, it totally is.
That is
totally
very
is.
obvious.
So that squealing you'll hear, that was me, sorry, filming in the background. But that was the moment that Luke's partner, Mira, spotted a meteorite. Now, Mira isn't even a planetary scientist. She joined us because she was part of Luke's household, and we had to minimize the number of households that were with us on the hunt. And so she's not even a planetary scientist. She joined us on that Saturday, and she had spent, given it was a sheep field, there was a lot of sheep poos in that field. So she spent that first hour of the morning. She'd seen something and go, "Oh, is that a meteorite?" She was very enthusiastic. And Luke would say, "No, sorry, it's a poo." This happened about 8 times. And then it got to this thing. And well, you can see it's even literally next to some sheep's wool. And she really stood there and was like, I feel really guilty. I keep stopping the walk, but I really do think this doesn't look like a sheep poo. So I'm actually going to say, look, I think this is a meteorite. And I'm so glad she did, because it is beautiful. It was the biggest intact piece of Winchcombe that's been found. You can even see the sort of fusion crust as it's come through the atmosphere on there. And really, if you look at it, it's a picture of my supervisor sort of next to it. It really got deep embedded in the ground. So she did a great job of spotting it. So we celebrated, but we had to find the landowners first early on Saturday morning on this enormous estate. So that was my job. I was running around. I think I was in my wellies, so that was fun, to try to find this woman who owned the land to say, "We found a meteorite. Would you like to donate it to the museum?" And thankfully she did. And even nicer still, one of the other people who lived nearby even gave us some whiskey to celebrate. And then it was a job of, well, let's dig this thing out of the pit that it made in the ground. It really got quite deep in there. And we only had one glove at this point. We really didn't expect to find any. We were just excited enough to just go searching. But so it was quite fun to think how, just Luke had one glove and a couple of bags. So yeah, given we didn't have much to go with at this point, all our universities were closed, so there wasn't much we could collect before we left. And we could do some sophisticated analysis before back in the hotel as well. So we reckon we picked up about 2 chocolate bars weight worth. But meanwhile, some slightly more professional stuff was being done back at the museum with the pieces of Winchcombe that had been collected from the driveway. That Waitrose Essentials bag. We also had some Waitrose Essentials cottage cheese and double cream that had been collected some of Winchcombe as well. So this is, during that week, our amazing curators at the Natural History Museum had already started cataloguing all the pieces so that we had loads that we can study. And that's what we already started doing. And what's even better is that the public can now see Winchcombe Meteorite on display at the Natural History Museum as well. And cooler still, the lovely the Wilcox family of Winchcombe have even donated their driveway. So you can see that on display at the Natural History Museum as well. And I would like to say just a big shout out to the RAS as well, because they've actually given the Wilcox family a honorary fellowship to the RAS, because the Wilcox have been so amazing with loads of outreach and education and just basically telling the public so much about planetary science through this whole experience. Like, they didn't even need to donate the meteorite for free, but they've done that, and then they just did so much more. They've gone into schools, they've gone all over TV and radio, and just really raising the profile of astronomy and geophysics through this. And it's just lovely that the RAS have recognised that. So the meteorite has had its official classification now. It is a CM chondrite, a carbonaceous chondrite, which is a really exciting meteorite. It's also exciting because it's the first UK meteorite recovered for 30 years. And it's the first one with a known orbit. So we know exactly where it's come from. And that's because of that camera detection that we've done. We've been able to track it back where it's come from in the solar system. It's the first ever carbonaceous chondrite. So that's the type that it is. I'll tell you why, that's cool in a second. And it's so pristine, especially that piece from the driveway, that you can kind of compare it to sample return missions. So these are missions that go into space and collect pieces of asteroids or pieces of the moon and bring them back. That's pretty much how good this is, because we know where it's come from in the solar system. And this thing wasn't rained on, it was collected within hours and studied within like a couple of weeks. So for a fraction of the cost, like missions cost millions, if not billions of pounds, this was the cost of a few cameras and some amazing citizen science. We've been able to get over 500 grams of asteroid, which is incredible. So this is where it's come from. It's come from the outer asteroid belt, so between Mars and Jupiter. Beautiful little thing. And what is it? Why is it cool? Why is it so amazing? So it's because it's from an asteroid that's been completely unchanged for over 4.6 billion years. So there's no real geological processing that's happened since then. And it contains about 2 to 3% carbon. Now that's really cool because all living things on Earth are based around carbon. So organic molecules that makes up everything that we know of as alive. So maybe things like this is what brought the building blocks of life to Earth, and not just building blocks of life from a carbon perspective. They might have also brought the ingredients that life needs to survive, because these meteorites are also, they contain up to 15% of water in their minerals. So maybe they're what delivered some of the Earth's water as well. So super cool. And so much so that when I actually got back from being part of this search team, which was incredible enough, I got home on the Tuesday after a week or so of searching, and it was the same night that the press release came out. And on the next day, my supervisors said, okay, you need to stop your thesis now, and you've got to plan an experiment to do a week later in the lab. So literally a week later, I was in the lab, having not had any access for over a year. And it was, the heating had broken. That's why I was wearing a down jacket under my lab coat, because it's Glasgow in April or March, sorry. And what I was doing was crushing up a small tiny bit of Winchcombe. And then I was putting it into, oh, sorry, that's the wrong one. There we go. Oh, no, it's being weird. Should be another section. Oh, well, we'll just skip it. There we go. So I was crushing it up, and then I was basically weighing out tiny little amounts of Winchcombe into tiny little vials, which was a little bit stressful. I'm quite clumsy. And this was obviously very valuable. If you look up Winchcombe now, the stuff sells for like hundreds of pounds for like 0.1 of a gram. It's mental. It's so, because it's so precious and so special. And here was I being trusted with it, and like on tiny bits of foil, if I sneezed, I would have lost it all. So I was crushing it up, putting it in tiny little vials, and then I was dissolving it in organic solvents. So these are just chemicals that would basically dissolve all the organic molecules, all the carbon-based molecules in there, that we'd then put in a fancy machine that would tell us like what it's made of in terms of those building blocks of life. And so far, so good. So in terms of the work I've done, it looks like there is some really cool complex organics in there, some surprises too, so not necessarily stuff we'd expect to find. And it has just been a wild ride. It's been an amazing thing to be a part of, because we have kind of treated it like you treat a mission. We've all been put in different teams in terms of analysing it. So depending on what your specialty is, you're studying different parts of the stone in different teams across different universities. But we had to just do that suddenly. And for a mission run by NASA or ESA, they'd spend years planning this, but we had to do it in weeks, and while in lockdown, which have made everything more tricky. So, but it has just been amazing. And the public engagement was amazing, just how much everyone got excited about it. And we were so worried that people would just be so mad at us for rocking up, but it was the complete opposite. And even so, it even got such a big deal, it even made the private eye. So I said about how we kept picking up poos. Well, they said, no, you haven't found a steaming piece of meteorite, it's a fox poo. So yeah, that's me. I think the plan is that me and Sheila are going to have a little chat first of all, and then for maybe 5-10 minutes, something like that. And then while we're chatting / now, if you can come up with any, chuck some questions in the Q&A, and then she'll just open it up and ask any questions that come in through the chat. But thank you so much for listening. Thanks for coming along. It has just been the most amazing opportunity to be part of. Looking back, it's still I'm still so excited. You probably can tell just looking back at it. Just totally wild. So thank you so much.
Thank you so much, Áine. That really captures your excitement and your enthusiasm. And I kind of felt like I was in the car with you when you were showing those videos. And I don't think how you feel is daft at all. I just think it's really exciting and heightened given the fact that it was in the middle of a global pandemic. And like you said, you'd been in your flat for however long, and then all of a sudden you were, down the motorway. We've got quite a few questions. So I'm going to go between questions that I've thought of and questions from the audience. If you do want to ask a question, please post them in the Q&A on Zoom or on YouTube as well, and we will get to as many as we can. So first of all, from Derek Robson, in all the excitement, did you experience anything weird? So, for example, he says when he found a fragment on going home, he ended up driving the wrong way on the motorway, quickly realised and did a U-turn, but it was the adrenaline, the excitement of the find. So how about yourself?
Yeah, I mean, we were a bit, so the actual moment, so you've seen the moment I filmed just there. That was I thought that was probably about 3 seconds after the initial, we were all just like, what's happening? So that initial we found something, then we were like, oh, right, what do we do? So it was a kind of funny thing. It was strange. So there was quite a few hiccups, I'd say, because for one thing, we couldn't find the landowner for ages. We found there were tenants on the land, and I went and knocked on one of their doors, and they didn't believe who I was. They were like, you could be anyone turning up. Why would I give you their number? So I was asking for the number for the person who lived in the main house. Yeah. And they were like, you could be anyone. Why would I give you? You've
been like COVID police or something.
Yeah, literally. Or just like, I think that they're pretty well off. So like, I think that, and it just obviously sounds pretty to any person. I found a meteorite on the sheep field down there. Like, obviously that sounds fake. Do you know what I mean? And especially because it was like 9:30 on a Saturday morning. So yeah, there was a lot of, and because I could barely speak. I was so excited. I probably, who knows what this person thought of me, because they basically shut the door in my face. And then it was the person with the whiskey who, after having this door shut in my face, I thought, okay, I need to regroup, calm. How can I explain this without losing it? But luckily, the Cotswolds is quite a tight-knit community. And this is what the lovely thing was, actually. Most people we met were so lovely that this person next door had kind of heard the story, and basically was like, oh, you're the meteorite people. Like, oh, of course, I've heard about you. There was one in the next village. Blah, 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 blah. So they were really happy and just were like, yeah, totally. Just completely happy to sort us out. But yeah, it was a funny time, and we just, I don't know, hard to put into words really, but yeah, I could totally see how you would end up driving the wrong way down a motorway, because we were just, especially because it was massive, like the piece was like this size. We thought if we were going to find any, we'd find a pile of smashed up stuff, but this was the only big solid intact bit as well. So absolutely wild, to be honest.
I got quite a few questions around composition. So okay. I'm going to sort of read them all out and condense them, and then you can answer as a whole. So okay. Let's have a look. So has an abundance of C12, C13 been determined? What compounds have you found so far? What about the organic analysis? Has anything been found that's unexpected? Do you have any data yet on the water signatures? And then the sort of all to do with the carbon and water content. How are they significantly important? How does this link to water on Earth? That kind of thing.
Yeah, okay. So I'll start with the organic analyses. I can't say loads because it hasn't even been submitted. So there's like one big paper, it's going to have like something like 100 authors, it's a bit nuts, that we've written as literally everyone who's done the preliminary analyses, we've all put in like a couple of sentences, plus like the biggest supplementary materials you've ever seen in your life. So that is about to get submitted. with basically, we found a thing, we've got its orbit, here's some cool stuff we found from all the different stuff. So hopefully that'll be out really soon. But basically, it is kind of what it's sort of what you'd expect in terms of CM chondrite, so, but slightly unusual. So there are things like amino acids in terms of the organics, but maybe slightly less than you'd expect. So we think that there's perhaps been maybe not as much alteration perhaps than in some parts of it, but we don't really know. We're still trying to figure that out at the moment when it comes to the organic side. In terms of the C12, C13, that was one of the first things that was done, actually. I think literally when Richard went to that driveway, I think he took a bit back to the OU and did some isotopes work. So the first thing he did was oxygen isotopes, and that was how straight away they knew, yeah, it's a CM chondrite. I think possibly by the Wednesday, having collected it on the Monday, which was just mad. Like, nothing in academia happens that fast. But it shows just how, especially in lockdown, like, no one could do anything. So that was pretty cool. I think, C12, C13, I think Monica Grady's team at the OU have done that, like from a bulk perspective. Don't think it's done from a compound specific thing. So like looking at, if you look at that molecule, what's its carbon isotope ratio? It's quite hard to do. One of the things that I'm looking at doing is looking at individual organic molecules. Can we look at the deuterium to hydrogen ratio? Which would be amazing, because one of the big things in space is that the deuterium to hydrogen ratio is pretty distinct in different parts of the solar system. So that's one of the things I'm trying to do with Winchcombe, because we have so much of it. And we have some really clear cut, like this is definitely from space, because what was handy about it is we could literally pick up the soil that it was next to. So we could rule out the kind of contamination from next to it as well. So I was using the sort of soil environmental samples, so we could like cancel out a bunch of stuff too, which was handy. I've probably forgotten what else. There was other content stuff, wasn't there? Sorry.
Yeah, no. What else was there? It was to do with anything surprising, and does the sort of water content link back to how much water there is on Earth?
Yeah, I don't know so much about that side of things. That's more like the mineralogical people look at that side of things, and which is not really my team. But there have been some bulk DH stuff done, which I think would look at that as well. Yeah, I believe that has been done. Because part of the thing is, where did the Earth's water come from? And you could do that with isotopes. I guess that's not been my side. I am very much in thesis writing mode at the moment, so kind of hard to have a grasp on what. I think there's something like 30 different universities, each have like 10 people working on this, so it's quite hard to know what everyone's got. Plus, there's only so much we can say before anything gets published, because it's obviously quite a high profile thing. But it's certainly very interesting. It's not totally bog standard. There's been exciting things, and we've got this one paper we're all doing together, and then we've got like a special issue of, so there's a journal that is just for sort of meteoritics, and we're all sort of putting in our little teams papers together for that, which will have much more detail. And I think the plan is just for everyone to put in for that in the summer. So hopefully sometime, I guess, early next year, all being well, there'll be much more information out there exactly about what's in this thing. But what I will plug is this summer in Glasgow, we are hosting the main Meteoritical Society meeting, like the international METSOC meeting, and there's going to be a special session for Winchcombe alone, and we're going to have a piece of Winchcombe on display in our museum here for the public as well. So there will be that'll be the first real opportunity for a big, like, what's going on with Winchcombe. So for any planetary scientists listening, that would be a big opportunity, especially if you're based in the UK.
That sounds very exciting.
But it will be hybrid too, so yeah. That's
probably even better. Are you going to, or have you been able to use any of the Winchcombe findings in your PhD?
Yeah, so it's, well, kind of. It's there as an appendix, because it was obviously never planned for a space rock to drop out of the sky when I planned a PhD. But it is really relevant, because my PhD is all about the organic matter, mostly on Mars, but where did Mars get its organic content from? And the two prevailing theories are like, was Mars born carbon rich, or did it have carbon thrust upon it or something? And if carbon was deposited on Mars, which it should be, then it would be through carbonaceous chondrites. So I've basically done the same experiments on Winchcombe, which we've done on Martian meteorites. And so what I've been able to do is compare the results and look at the individual molecules and say, are they similar? Are they different? What kind of stuff's in them? And therefore, could a meteorite like Winchcombe have been the origin of where Mars got its organic molecules from? So it was amazing timing for me in terms of my research. And it has added a whole extra chunk of work, and that's why I'm now 4.5 years into my PhD, because it's basically a whole year's extra stuff. But we also amazingly at SCFC have paid me to do this work, so that's why it's kind of an appendix, because it's sort of an extra job on top that I've been able to do. So really amazing. Yeah, you don't exactly plan for that happening.
No, definitely. I think that's I imagine, you know, for anyone doing a PhD with this sort of thing, wouldn't ever imagine it to actually, you know, this kind of thing to happen during.
Yeah, it's funny because the people at Australia, so at Curtin, they're the ones who set up the big fireball observatory there. It's a bit of a different ball game for them because they have this massive desert and also huge dark skies, just order of magnitude bigger space to search for these things. And so they have had quite significant successes with this. And that's where we took the model from in setting up the UK fireball network. So it started off in the desert in Western Australia. They got loads of funding, and basically we got their cast off cameras as they upgraded them over there. And it's meant now, I think they've had something like 8 or 9 just in this, I think only about 10 years maybe, the fireball network's been going. I could be totally wrong, but it's been a fair few, certainly, that they've managed to collect from the desert fireball network, or maybe that's globally, but certainly that model has been shown to work. And now we've applied it in the UK in much more difficult terrain. Like you compare a desert, like black on sand is much easier to spot than like black on green where it could be poo. So
sort of talking about poo, a question about cross-contamination, and how do you deal with contamination for it landing in a field? Do you have to clean it before you test it? Things like that.
Yeah, great question. So that is a big thing we've been trying to work with. So the main thing you can do is, first thing you do is you want to take an environmental sample from close to it as you can, so immediately next to it. You want to collect it as soon as possible. There's then other bits you want to do is things like if you're looking at organics, you want to look at the interior sample, so nothing around the outside. You can also do funny things like the surface area to volume ratio of your sample. If you crush it at different sizes and the amount changes, that can tell you different things as well, because if it's uniformly all the way through, because it's indigenous to the material, whereas if it's contaminated, you'll get different concentrations based on how much you've crushed it. There's lots of different things you can do, but the like number one way is getting isotope ratios, because then you know it's not from Earth, because things like hydrogen is just so different. Other things you can do is look at amino acids. This isn't a technique, so I use liquid chromatography mass spectrometry, which sadly can't do this, but other types can. So amino acids are all either left-handed or right-handed, so you can't put them on top of each other and make them like match. And if you're biological, they're all biased one way or the other. So biological processes, I think most of them prefer to be left-handed. So if you've got amino acids and most of them are left-handed, you've probably got an Earth-based biological sample, because asteroids aren't alive. As far as we know. Whereas if your amino acids are 50-50 left-handed, right-handed, you're pretty sure you're going to have space-based extraterrestrial amino acids there, because that just doesn't happen biologically, if you see what I mean. Like, it's not a natural process, because biology like prefers it for energy or something. I'm not a biologist.
That's really interesting. On detection, so how often are they detected? Are they generally detected on land or in the sea? And also, you talked about people like Mira who isn't her job, and also you showed a picture of someone with a tiny little bit. How do you detect, from big to small, and do people need special training?
Yeah, great question. So in terms of frequency, modelling suggests there should be about one a year that falls in the UK, which is why we were really overdue. So the fact we hadn't had one in 30 years, something was really going wrong. So it's really good that we, got this camera network, we got the alliance, etc. A big part of it is getting lucky with weather conditions, because if it's a cloudy day and no one sees the fireball, you're stuffed. Like, it could be anywhere, right? So that's a big part of it. In terms of knowing what to look for, a lot of it is it a black rock where it shouldn't be? And then ask a specialist, take a photo. If they're heavier than a rock would be, that's the same size, but don't pick it up with your bare hands because that contaminates it. Ideally store it in foil, like fresh foil, or like a Waitrose Essentials sandwich bag, or ideally a bit of both, because it's interesting, like different techniques prefer it to be stored in different ways. So my analysis, I would like it to ideally have not been stored in plastic, because plastic is an organic material and that's kind of a contaminant. But people who look at some of the isotopes, so rhenium, osmium is one of the things we can do to look at the dating of this thing. That can get quite influenced by foil. So one of the lessons we've sort of learned with this is that ideally next time, if all the stars aligned, shooting stars aligned next time, what would be great is if it was a team that found it, we'd store some in different types of sample storage, and they'd be designated for different teams, because depending on what analysis you want to do, you don't want to have it interfering. Like, for example, you don't want to go near it with a magnet, because there's a bunch of people at Oxford who look at the magnetism of the stone, because that can tell you about how the asteroid was formed. But if you put a magnet near it, that wipes that history altogether. But magnets are also really useful as a way of detecting meteorites, because something like 99% of meteorites are magnetic. So it's like, it's a kind of win-lose situation. Like, you'd lose out on a lot of the interest, but you'd make it a lot easier to find.
Right. So if I see a piece of sheep poo that I think might be something else, I'd go and get a magnet to it, wrap it.
The main thing I'd say is get pictures, record where it is, and contact the UK Meteor Observation Network or the Natural History Museum, and they'll tell you what to do. If they think the pictures look reasonable, they'll get in touch. So
when you were out there looking for these black rocks, were you ever tempted to pocket a bit to sell?
Oh, absolutely not. If it was on private land, it belongs to the landowner, and it's a really like rigorous thing that has to happen. And it actually there were different processes for different people, and some landowners chose to sell it, and that's their decision. It's really valuable, Some bits are costing, I think there's one on auction, parts of it on auction just now, obscene amounts of money. So yeah, personally, it was like, for one thing, it's only valuable while it's still really fresh and kept in the right environment. If I'd have pocketed it, it wouldn't actually it would have gone to mulch. Like, it's like a bath bomb almost. It's just powdery, that's kind of why it went to nothing on that driveway, because it's so, yeah. Some meteorites, like iron ones, are really hardy and stuff, but this one is so not so tough that it really was so valuable because it was collected so soon. Mm-hmm. And the NHM were able to keep it in a really special container and things like that. But honestly, that's been what's so good about it, is we're able to have so much that so many of us have been able to study it, and it's there in the collection for people to apply to use, and also have a whopping great big bit on display for the public. And even better, there's a bit on display in the Winchcombe Village Museum. So we got funding for a special container in the Village Museum for anyone who's visiting Gloucestershire to go and see as well, which is just lovely. So it's just like the most wholesome thing.
Really community thing, yeah. You sort of mentioned that it was kind of like bath bomb type feeling. Does it smell? Do they pieces?
Not okay. That's a really good question, because there are other meteorites in this classification that stink. So there's one called Murchison, which is in the same type as Winchcombe, which like really famously really badly smells because of all the organic molecules. Now the funny thing is I was in the lab with a face mask on most of the time doing this stuff, so I don't know if it's partly that meant it didn't, and I was in a lab that was like there was heating problems that meant the ventilation was on haywire, so, and also it's in like a fume hood thing, so I wouldn't really have smelt it much anyway when I was doing this work, but I certainly didn't notice it in the same way you're kind of meant to when you supposedly when you open up a thing with Murchison, it just like it like stinks straight away because it's got so much organics in it. But this doesn't, certainly my experience was it's nothing quite at least like Murchison anyway.
That's probably good to know, I think. You mentioned about the fact that if it lands on someone else's land, so then it belongs to them. Is that right? What happens if they don't let you have it, or they won't let you take the rock with you?
Yeah, so basically it's theirs. So one of the things that happened, there was a bit of a, you just have to, one of the things that could happen is it could go to the museum's collection and then they could decide, well, they want to keep it and it goes back to them, or it could be they just say, no, I want to keep it, and it got sold to a collector. That's one piece that happened. You know, it's just, I think it's the same as treasure, perhaps. Anyway, essentially they have to get there, and then we collected it, took it to the museum because we've got a verbal agreement, but then like much more important people at the museum then dealt with very formal signing off. It's like, because it's a charity, it's effectively like a charitable donation was how it was agreed. And so lots of really formal stuff, because it's a valuable thing, had to happen to just prove that, like, yes, you definitely want to donate this. And yeah, there's all kinds of funny complications that can happen. Like, whose land does it belong to if you're a tenant versus if you're a landowner, for example? Like, what happens there? It's really tricky. So yeah, we were really lucky. Like everyone, we did 5 days of searching, and there was only one person who didn't want us searching on their land. Everyone else was so welcoming, which you totally, like, you could be forgiven for not expecting it. We were certainly so nervous when we arrived because it was the middle of lockdown. There were people from Plymouth, from Manchester, like Imperial, all over the UK, and us from flipping Glasgow. Like, you could be so easily really worried, but everyone was just so happy and so welcoming and so excited this was going on in the area. And that was the best bit, was just the people of the Cotswolds, people of Gloucestershire, just being so kind and so excited for us and just so happy for us to let us on their land. And we were always open from the start. We said to them, look, this is what we're here for. If we find one, we'll tell you what it's worth, and you'll have the option to either sell it, we'll buy it off you, or you can donate it, or you could not, you could keep it. But obviously we'd really like you to give it to the museum, because that means the scientific community gets it. And that is what I think 5 people who had by far the biggest pieces did, which is why now we have so much as a scientific community in the UK and beyond to study and to keep for future generations as well. There's that much that it's there for a long time now, which is amazing.
Do you think it's worth going back to Winchcombe? Do you think there are bits that haven't been found?
There might well be, but I know fine well that meteorite collectors have scoured it since. There's been a lot of these tiny little pieces that have been found by collectors in the meantime, so you'd be lucky. Plus, it's now been a year. There's been so much that have been rained on, like the value would have gone down because it have weathered. It might have just gone to mulch by now, but you could try. No reason you can't try, but I'd be surprised because I'd have thought it'll have been scoured to the nth degree by now.
Yeah. So you mentioned that it was the most recorded fireball sort of on history. I don't know the stats. Do you think that was partly because of the rise in social media, the internet, etc., or do you think it was to do with COVID and lockdown and lots of people being at home, and how did COVID sort of affect this whole process really?
Yeah, I think all of the above, really. I think the fact it was a Sunday evening, I think, big part with dash cams, doorbells, what do they call it, Internet of Things. So much of it was that, those little cameras, Twitter, just the fact that people didn't have much, wasn't loads else going on. Everyone's worlds got loads smaller. When you do those Google Trends thing, if you search that for the whole of 2021 and you do meteor or fireball, you see the massivest jump for the 28th and 28th of March, 1st of February, 28th of February, 1st of March. So it really shows how much it engaged people across the UK. COVID, in some ways it made it, well, definitely there are a lot of ways it made it harder. If as soon as we'd have seen the fireball originally, I think we'd have just gone as soon as they'd run the maths. But because of lockdown, we had to wait until we were pretty sure there was the piece. And then we had to get all these approvals. I'd say the hardest thing was we couldn't go to the pub in the evenings. So we had really long days. There was like 20 of us all in little groups doing different bits. We couldn't even sit together in the same room in the evenings with a map and like work out where we'd go. We'd had to sit in our hotel rooms each on Zoom together in our own rooms, share screen with like OS maps, like sharing screen, pointing with our cursor, being like, right, who's going to go where the next day? We couldn't even just sit in the room together with a map because like that was too risky. So even little things like that just made that part of the field work really hard. So yeah, the lack of a pub to be able to sit in with a map and a pint at the end of the day to plan the next day was probably like the hardest part. And the fact that because we couldn't have so many, because of a lockdown, we really had to keep numbers as low as possible. It meant we couldn't cover everywhere really quickly. The word kind of got out before we'd covered everywhere. So we had to leave before we knew like all the news was going to be on the doorstep and we'd all get just like harangued. And we didn't want to be there by the time Sky and BBC and everyone turned up because we just thought it'd be a bad look. So that's kind of, we probably didn't cover everything we would have wanted to, but we did a huge amount of when you see my step count, we covered a lot of ground.
So just to start to wrap up, unfortunately the hour's gone really quickly. Just quickly, what's next for you and for Winchcombe?
What's next for me? Well, I've got 2.5 months left until I've got to submit my thesis. So, in terms of what's after that, who knows? But I would love to continue working on it. One of the things we are putting in at the moment is my supervisor is applying for some funding so that I can continue working on this because there's loads we can do. There's so much as a community. We actually had a meeting as our little organics team 2 weeks ago to get together with our data and say like, okay, who's doing what and what have we found? And that's been one of the best bits, is just being able to go down little rabbit holes and realize like we've all found these different cool things and we can all work together. And it really has brought people together when we all haven't had other chances to, which was it's just been such a lovely part of it for sure.
And a comment from the audience, more of a comment than a question, but great talk, Áine. Lovely to see the human emotion side of such an exciting find. It must have been amazing to be such a central part of the process. Fantastic. So I'd like to echo that. It's been absolutely fascinating. Your enthusiasm is catching, and I want to go outside now and just have a look at a few black rocks just in case. Thank you again for joining us, and thank you to the audience for all the questions. They were fantastic. We will be back next month with another public talk, and there are various events going on, mostly still online. Just have a look at our Eventbrite page, our YouTube page, or the RAS website. Thanks again, Áine, and thank you everyone.